Okay, hello everyone. Hello everyone, welcome back. Welcome back to Calc 1000. Today we are going to do a little bit more on implicit differentiation. I just want to do a few more examples and 2 or 3 small pieces left. I want to cover those ones. But today, we have a guest in our class. He's my office mate. He feels very lonely because none of you attend my office hours. His name is Newton the Rock. Say hi to Newton the Rock. Okay. Let's do this. I will post an iClicker question and say hi to him in the iClicker question. And let me clean this one up. Okay. Yes, please say hi to him, and this is the chance you have to make a joke, make him happy. I will read all the jokes that you write there for him, and I'll give you 2 minutes to do that. It's very important. Pardon? Just type in something, yes? Do you want to say hi?
Hi. But did you have like keys in your desk with like 2 pom-poms?
Was this the one?
I think it's my friend's.
Oh.
Thank you so much.
Okay, just make sure that you put something in because this is the iClicker assignment will be used for your for attendance. We will have another iClicker question today. So I will start with quick review of what we did yesterday when we were doing implicit differentiation. So remember that this method of deriving, it's not a rule. It is a way to use our differentiation rules for bigger class of functions. In this specific case, we are talking about functions that are implicitly defined through an equation. So we did 3 steps. The first thing is that you find the derivative of left-hand side. It must be equal to the derivative of right-hand side. The second thing was apply differentiation rules. And don't forget that when you're differentiating an expression in y, you have to have the derivative of, or the chain rule applied to that. So you cannot just say this is g prime of y. You have to multiply everything by y prime. And that step is very important. That's how you get the correct differentiation here. But also, that's how we do the last step, which is finding y prime. And then when you do this, you will find an equation for y prime, solve the equation for y prime. Isolate y prime. That's the other way of saying this. Okay? Okay, so let me see the first example I have. Okay, yeah, this is just another simple implicit differentiation. Find y prime if y is a function of x implicitly given by this formula. Nothing new, we're just doing more examples. Please go ahead and try to do differentiation on that one. And I'll give you 90 seconds to complete that. If you haven't done the iClicker, please do it now because I'm closing it. I will close it in 10 seconds. Okay. Differentiation starts always by this step. This is, you're not doing anything mathematically, but saying that the derivative of two equal expressions must be the same thing. And now I'm trying to find the derivative of cosine inverse of something. Remember the rules of differentiation. For cosine inverse of box, I'll write it as box, it's like the derivative of sine inverse. You have a negative sign multiplied to that. So it would be negative of box prime over 1 minus box squared. In other words, I have x, y prime, negative of that over 1 minus xy squared. And the right-hand side is, oh, well, that's easy differentiation. Here's 1 plus 2y prime y. Now, in the numerator here, what I have is, yeah, this is the product rule, yes? Derivative of first one, 1, times second plus first one itself times the derivative of second one, and then square root of 1 minus x y squared equals to 1 plus 2 y prime y. Now, I'm done with the differentiation, but I have to now isolate y prime, or solve the equation for y prime. In other words, I have to put all the terms which have y prime on one side and take all the other terms to the right-hand side. Here, I have y prime here, so I have to separate this from y prime. I know that most of you will multiply this there. That will work, but then again, you have to expand it here and then bring it over here. Instead of doing that, I will separate these two into this, that, and then I bring this to the left-hand side, and the right-hand side is only 1. Well, I actually need to take this one to the other side as well. So the right-hand side will be 1 plus y over 1 minus x squared y squared. And now in the left-hand side, I only have these terms here, and both of them have a multiple of y prime. I factor out y prime, and I get negative x over 1 minus x squared y squared minus 2y. The only thing is left there is divide the coefficient of y prime, the right-hand side by the coefficient of y prime. So I have y prime is equal to 1 plus y over 1 minus x squared y squared minus x over 1 minus x squared y squared minus 2y. Simple differentiation facts there, yes? Any questions, any comments? You can simplify, but I will leave it as is because simplification is not the point of this question. In general, differentiation needs to be done. Once you get something like that, you can leave it like that because I don't want to check the differentiation rules. Another example, find all the points on the curve that have tangent line to the curve parallel to y equals to x plus 1. Find all the points at which the tangent line to that curve is given by a line parallel to that given line, y equal to x plus 1. Before I give you some time to do that, I just want to know if two lines are parallel, what kind of information we have there? Yes, please.
Same slope.
They have same slope, yes? So in this case, the slope of this line is 1. If you write it as a slope and mx plus b form, the coefficient of x is what you take as a slope. But we also know that the slope of tangent line is given by the derivative of the function or dy dx, the changes of y over the changes of x, when you plug in that x dot, y dot. What does this question basically say is that find the points at which m of tangent line, m tan, is equal to 1. Okay? I'll give you 2 minutes to work on this yourself or with the friend sitting next to you. The important thing is that you start differentiation and set it equal to 1 and then see what happens next. Go ahead, please. 2 minutes starts now. 30 seconds left. So we start with differentiating both sides with respect to x. And that means that I have 4x cubed plus 4y prime y cubed equals to 0, because y is a function of x. When you're differentiating an expression in y, you have to apply chain rule to that. And this tells me that, OK, isolating y prime is not difficult here, yes? So it gives us y prime must be equal to negative x cubed over y cubed. And we know that y prime at the point that we are looking for must be equal to 1. So in other words, y prime must be 1 implies that minus x cubed over y cubed must be equal to 1. And that means that cube of two numbers are negative of each other. That means the x and y must be, or doesn't matter which one we write. I don't know which one. It doesn't matter, actually. OK. Doesn't matter. You get that. So what we have here is that it says, it doesn't give me the point yet. It says the point of your interest will have this other relationship between the first and second component. We already know that the points on the curve satisfy this equation. Now we know more, which is y also must be equal to negative x. That kind of points is where we are interested in finding. So in other words, you have two equations, but this is easy. I just plug this one into that. I get x4 plus negative x to the power 4 must be equal to 32. That means 2x4 is equal to 32. Means that x4 is 16. And then that means x is plus or minus 2. I'm solving an equation, so that means that I have to put all the possible values there. OK, it means that at points where the points that have parallel tangent line to this guy, the first component would be points on the curve with a tangent line parallel to y equal to x plus 1. There are two such points. One has x component 2. The other one has x component negative 2. OK? And now, if I use the relationship between x and y that I found before, that's straightforward that I can find y. So if x is 2, y should be that. If x is negative 2, then y should be 2. Yes, please.
How does the x to the power 4 plus negative x to the power 4 not cancel out? If it's minus?
Oh, why it is plus and minus 2? Is that what your question is?
No, like why? So it's x to the power 4 plus negative x to the power 4
This one?
equals 0.
Here, for y, I'm plugging in negative x. Then I get this equation. Yes? And negative x to the power 4, negative 1 to the power 4 is plus, so you get 2x to the power 4. Is that good? Yeah? Any other questions? Any? Yes, please. The derivative of y prime dy dx on any given curve is equal to slope of the tangent line. Yes, that's right. Any other questions?
And then it's like in bracket.
Well, if you don't like to ask me, you can ask Newton the rock. Well, you just need to drop by my office. And I have another iClicker question, which is about the slope of tangent line for the implicitly defined. Could you please confirm that you can see the question clearly there? Thank you.
I don't know what it's actually. It's like so bad.
So we are looking for slope of the slope of tangent line to this curve at that point. I'll wait another 90 seconds for that. It says that the point that we are looking for, it should have the y component equal to negative of x component. When I said y prime equals 1, the last line on that board, I got negative x must be equal to y. So if I find x is 2, y should be negative. That's right, yes. So, that's right, yes. Another 30 seconds, and then I will close the poll.
Just decided to combine my questions.
Okay, I'm closing the iClicker in 10 seconds, please. Okay, slope means find the derivative. And evaluate it at that given point. Oh, before I do that, before I find y prime, how do you know that that point 1 and pi over 4 is a point on the curve?
Plug it in.
Plug it in. And, well, in the question, the way it is written, maybe it's not required. But I want you to develop this habit of, if someone is asking you to find tangent line or anything along those lines, first check that the point is on the curve. In other words, if I plug in 1 into x and y, and pi over 4 into y, then I should get an equality there. Tan inverse of 1 is tan inverse of 1, pi over 4. You should know those values. This is pi over 4, and the left-hand side is pi over 4. Yes, that is a point on the curve. It means that I just need to find y prime and plug 1 for x and pi over 4 for 1. So this one is product rule 1, derivative of first one times second one, plus first one itself times the derivative of the second one. And the differentiation rule for tan inverse, I'll write it here just for you to recall that again, is 1 plus box square in the denominator, and the derivative of the box should appear in the numerator. So in this case, I get 2x, 1 plus x squared squared. You can plug in what is x, what is y, and then find the value of y prime that you're interested in. Or I would like to solve this carefully and get 2x over 1 plus x4 minus y, and then y prime is, divide that x over here, so this will be 2x over x, 1 plus x4 minus y over x. I really don't need to simplify much there. That's the derivative. And then when I plug in x equal to 1 and y equal to pi over 4, I get y prime, or the slope of the tangent line, equal to 2 times 1 over 1 times 1 plus 1 to the power 4 minus pi over 4 divided by 1, which gives us 2 over 2 is 1 minus just pi over 4. And that is nothing but the slope of the tangent line at that point of that curve. Any questions, any comments here? Any questions, any comments? Okay, then let's do this last piece, and then we are free to go home, or you're free to go home. There are 2 examples, not 1 example, please. Okay. The example that we already did, forget the tangent line thing. We tried and we did all the work. So for the x to the power 4 plus y to the power 4 equals to 32, what we found was that y prime is negative x cubed over y cubed. Yes, we did the calculation. And, well, we know how to do it now. Yes, differentiate both sides, apply the chain rule when there's a y term, and then solve it for y prime. Now, the question is this. If it is explicitly defined, you can differentiate how many times you like, yes? You find the derivative, that's the function, differentiate again, that's the second derivative, differentiate again, that's the third derivative. But here, the function is not defined explicitly. It is implicitly given through that equation. I'm going to give you 40 seconds, and I'm not expecting you to solve this. What I am expecting you to do is talk to the person sitting next to you, and you want to see if you can answer the fact or figure out what is the mathematical work that you need to do after you did all these work or over there to find y double prime, or the second derivative of y implicitly defined like that. 45 seconds, you're talking to a friend about this specific question. No one is talking to their friends. Talk to your friend. I need to hear a bit of chat there. Okay, to be able to, I'm going to give you another 30 seconds, but I'll give you a hint here. Maybe some of you already figured it out, but the hint is you just need to know what is the definition of second derivative. That's simple. Meaning that second derivative is nothing but the derivative of the first derivative, yes? And you already have the first derivative. This is an expression of x and y. We have been differentiating such functions since yesterday, such expressions. Now it's your turn, or maybe another 45 seconds. Knowing that fact, go ahead and do the calculation. Now you need to do some work on your notebooks or tablets and try to evaluate something. Maybe another 30 seconds, so those who started the work can finish it.
How does tan inverse of 1 equal pi?
What is the angle whose tan is 1? That is the meaning of tan inverse.
Okay,
Yeah.
that's not
Yeah, yeah. Okay, so I'm differentiating y prime, but y prime is an expression in x and y. Well, that's the chain rule. I'll apply the chain rule. Here, the derivative of numerator times the denominator minus the numerator times the derivative of the denominator. The same story works here. Y cubed, if you differentiate with respect to x, it is 3y prime y squared divided by y cubed squared. Done. We differentiated. No, that's a lie. We are not done. We differentiated, but we are not done. The reason is that, see, in the implicit differentiation, the function is given as an expression of x and y. The derivative is also an expression in x and y. The second derivative, you should also write it as an expression in x and y. This expression here has also y prime. Are you going to answer how that to get rid of that y prime there? We already have y prime in terms of x and y. You just plug it in here, and then that will be the final answer. Minus 3x squared x cubed plus 3x cubed. Instead of y prime, I'm going to plug in negative x cubed over y cubed times, times y squared. And that's the expected work from you to do, that in the implicit differentiation, doesn't matter which order, at the end you should give me an expression in x and y. Any questions? Any comments? Yes, please. You can simplify there, yes? As always I say, at this point, I'm not worried about simplification. I need to see you guys are doing all the steps properly. Was there another question over there? Or maybe that wasn't a question. Any other questions? Any other comments? Wow, we're finishing 10 minutes earlier? Wow, that's a lot of time. Okay. Have a good weekend. Enjoy your Thanksgiving. Newton the Rock is here. You can come and say hi. Someone asked, can I pet him? Yes, you can. I will wait here until the class time is done.